Okay, this is the third presentation.
Good morning, good afternoon, or good evening, wherever you are in the world. There has been a lot of recent work on autoregressive speech recognition, but not as much on non-autoregressive ones, even though non-autoregressive models have advantages. From the literature, we know that both pre-training and scaling up model size improves performance, but scaling up model size naively can lead to the problem of overfitting. The main idea of our paper is to combine large parameter models with pre-training to reduce the problem of overfitting, and by doing so, achieve a new state-of-the-art for non-autoregressive speech recognition. Our model architecture consists of a conformer encoder followed by a CTC decoder, which consists of a linear layer and softmax layer. The conformer encoder consists of a series of conformer blocks which have feed-forward, convolution, and attention modules that are attached to a layer normalization at the end. To explore the effects of pre-training as we scale up model size, we experimented with two sets of models, the base models which use standard training, and the pre-trained models which use Wave2Vec 2.0 pre-training. And the pre-training is done on LibriLite, which has 60,000 unlabeled utterances. Wave2Vec 2.0 first masks encoded features and computes context vectors from them. The encoded features are also passed through a linear layer in our version of Wave2Vec 2.0 to get target context vectors, and contrastive loss is computed against the context vectors from the masked and unmasked features. And at the very end, we fine-tune on the downstream dataset. Our models range from 9 million to 1 billion parameters across the base and pre-trained models, and we evaluate the word error rate across LibriSpeech, Switchboard, and Wall Street Journal. But we can clearly see that for the base models, initially the performance improves, but then ends up degrading with our larger parameter base models. For our pre-trained models, however, we see that as we increase model size, the performance continues increasing. However, for Wall Street Journal, we see that even at the very smallest models, we already begin to see the degradation. Pre-training does improve the performance, however, our 1 billion parameter also begins to degrade. And we believe this is because Wall Street Journal is much smaller compared to the other two datasets. Compared to prior work, our model is able to beat the state-of-the-art for all non-autoregressive prior work without language models, and can also beat some autoregressive works as well. Thank you for listening.